in this section, 5.1 and 5.2, we're going to see how the simplex method is going to help us solve the solution for a maximum problem. So your book, of course, divides sections 5.1 and 5.2, but the material presented in these two sections is so integrated that we're going to talk about them at the same time. So this video covers both sections, 5.1 and 5.2. So before we get into the details of how the simplex method for solving a maximum problem works, let's become familiar with a number of essential definitions. So first we're going to talk about the standard maximum problem. What makes up a standard maximum problem? We need to be very familiar with that. So this would be a definition of a standard maximum problem. And of course, we're learning about the simplex method. Okay, there are two conditions that make up a standard maximum problem. Let's see what those two conditions are. First of all variables are positive or must be positive. Second, are less than or equal to so all constraint inequalities are less than or equal to a positive constant. So let's see an example of this, these conditions. Suppose we want to maximize this objective function we already know what an objective function is, right? From applying the geometric approach, we know that an objective function is any function that where we're either looking for its maximum or minimum, nowhere in between. Okay, so that's the objective function that we want to maximize, and the constraint inequalities are as follows. (2x1 plus 4x2 less than or equal to 120, and 2x1 plus 2x2 less than or equal to 80. And here is the last essential piece, that x1 greater than or equal to 0, x2 greater than or equal to 0. So let's see how this makes up a standard maximum problem. First of all, we saw that all variables must be positive, right? So here is where that condition is met. both variables are positive, right? That's our condition. x1 and x2 must be greater than or equal to 0. So this condition, all constraint inequalities are either less than or equal to a positive constant. So where is that met? Where is that condition met? It's right here. Right here we can, here we have both constraint inequalities are less than or equal to a positive constant. So let me just say condition 2 so condition 2 is met, and this is condition 1, this one. Okay, so that's why we know that this maximum problem is a standard maximum problem. The other terminology or definition we need to be familiar with is the definition of a slack variable. Okay, so we might want to So this simplex method is a method based on matrices. Now in matrices, we can't have coefficients of inequalities. We must have equalities before we can import or use their coefficients in a matrix setting. So because of that, we need to convert each of the constraint inequalities to equations or equalities. What I'm talking about, let me bring back the previous slide. So each of these constraint inequalities, these coefficients, we're going to need these in the simplex method. But as they are, we cannot use them because they belong to an inequality. We need to convert each of these inequalities to equations or equalities. And slack variables are one way of achieving that. So for converting each of these constraint inequalities, we're going to need one slack variable. So we have two constraint inequalities. That means we're going to need two slack variables, S1, S2. If we had three constraint inequalities, then we would need three slack variables. One slack variable for converting each of these inequalities to an equality. So let me write down what I just said. So one single slack variable, and we're going to call them S1, S2, S3, and so on. So I should have maybe written this in red ink, but to convert a constraint inequality to an equality. So let's take the same example that I had before. Let's take this one and see how we're going to convert these two into equalities. I'm just going to use the same example or same constraint inequalities. And so using this, So if we have, so looking at that, suppose we want to convert these two to equalities, then we have 2x1 plus 4x2. Now instead of equality, we're going to, inequality, we're going to have an equality. So before that, plus s1 equals 120. So the inequality is gone, and now we have a slack variable. Let's convert the second inequality to an equality. So we have 2x1 plus 2x2 plus s1 is already used up, right? It's already been used up to convert this inequality to equality. So we're going to need second slack variable, s2 equals 80. Okay, so that's how it works. That's why we need slack variables. Before this, these coefficients we could not use in a matrix. These we can, and you'll see how that is done a few minutes later. Okay, so now that we know about slack variables, let's give the definition of the initial simplex tableau. So here's another definition. So a tableau is a special type of matrix. You're going to see these only in the simplex method. And they are kind of a special matrix. That is why we call them tableau. Okay, so let's see how this is done. We've already learned about the augmented matrix. So this kind of dovetails on that. So the initial simplex tableau is an augmented matrix. Of the coefficients of the maximum problem such that, so this is, the initial simplex tableau is an augmented matrix such that the coefficients of the maximum problem, such that the coefficients of the constraint equalities, we're talking about these guys. These are now constraint inequalities, and let me add, including the coefficients of the slack variables. So those coefficients are in top rows, and then the coefficients of the rearranged objective function in the row at the very bottom. When we get to actually a few examples, then you're going to see what all this means. But this is just in case you have to refer back to these definitions. You can always come back here and look at these, and hopefully that'll clarify any questions you might have. But we'll do plenty of examples on this. Okay. So that, and then, so before we do examples, I want to make sure that you know what a simplex or the initial simplex tableau looks like. That's all I want to make sure at this point, that you know how they look. Okay, so here's one example of an initial simplex tableau. I want to, even though we're not going to use this column, I want to mention it because your book mentions it, and I want to talk about it for that reason, but when we get to the method itself, we don't really need this column. But because it's in your book, I'm going to talk about it once. So, but BV means basic variables. That's the short for basic variables. And then P, that's the variable for the objective function, right? P. And then x1, x2, s1, s2, and then, of course, the RHS, which stands for the right-hand side. Like that. Okay, so what are the basic variables? The basic variables are dynamic. They change throughout this procedure, but the initial ones are the slack variables. So if we had 3 slack variables, they would the S3 would also be listed right underneath S2. And then, of course, P, this is the bottom row, the objective row. And so, and this first column under P, it's always 0, 0, 1. And this is, again, I'm using the same example. I'm writing the initial simplex tableau for this example. In case you're wondering, it's for this example. And so we have 2, 4, 1, 0, 120. Okay, never mind if you're wondering where these numbers are coming from, we'll get to all of that. But just at this point, all I want you to become familiar with is visually see how this looks. You have the right-hand side in the far right column. This I'm showing just as one example, but pretty soon we're not going to write that down. But that's where we begin initial simplex tableaus. So from P, X1, X2, S1, and S2. And the bottom row is the objective row. So this is the implementation of this text, which I just wrote down. So this is an example of how initial simplex tableaus look. I want to just so those of you who read the book, just to make sure that you understand what the book talks about. So these are called the non-basic variables. These are the original actual variables. These are non-basic variables. You already know about slack variables S1 and S2, but S1 and S2 are also called basic variables. That's just becoming familiar with the terminology here. So these are basic variables. And this bottom row, this bottom row is called the objective row. Okay, so at this point, just be familiar with that P in a tableau. P starts the variables across the top. Then come the non-basic variables, however many we have. If we have x3, x4, you would list them one after another across the top. And then come the basic variables, which are also known as the slack variables. But these across here will change. They are dynamic. I found that every time I talk about this in a solution, people tend to get more confused, so I'm going to omit them. The only place I'm going to mention them is now, but pretty soon you're not going to see me write this down. I'm just going to begin each tableau with this column, P001. And this is right-hand side column, and the bottom row is called the objective row. Okay, so that's basically the anatomy of an initial simplex tableau. Now that we've become familiar with the initial simplex tableau, let me just mention a conceptual note. By conceptual note, I mean I want to connect these ideas that we're talking about as we move forward. So conceptual note is a connection between what we've already talked about. So the simplex method begins with the initial simplex tableau, and ends with the final tableau. And we'll talk about this. Okay, so we begin with the simplex method. Begins with the initial simplex tableau, and it ends with the final tableau. Okay, so let's ask another big picture question, right? We always want to work with the big picture and then narrow it down to the details so people understand where we're going with all this. So that's the question we want to answer. How does this method work as a big picture, in the big picture? Okay, so first, so here are the steps we take in order to solve a maximum problem using the simplex method. For each constraint inequality, to be converted to an equality. Remember, we just talked about it 5-10 minutes ago. So that's what we do first. Then the second step That's the second thing we do. We move all the terms in the objective function to the left-hand side and set the entire objective function equal to 0. After we've done that, we're going to write the initial simplex tableau, right? This is the beginning of the simplex method. And then, so let me quickly connect this to what we've already said, that in the initial simplex tableau, the coefficients of the constraints are in the top rows, and those of the objective function at the bottom. Okay, and finally, use we'll talk about this, very important. Use Tableau pivot operations numbers from the objective row. Okay, so these 4 steps are the main steps in solving a maximum problem using the simplex method. And then there are details to each of these steps, and we will go through these step by step. Initially, I will write down. This lecture is going to be a little bit descriptive, but I have a point for this, because I just want to make sure that in the future, when you have a question, you can always come back to this video or to these notes and get your questions answered. That's why we have a couple of more pages of notes before we can actually go through a few examples. So please bear with me. So here's another question for us. On the previous slide, I mentioned number 4 step. The 4th step had Tableau pivot operations. Use that, right? So what are these pivot operations? We're going to talk about that now. Okay, it consists of a bunch of steps. Let's go through them one by one. So first of all, defines the pivot column. So recall that the bottom row of the initial simplex tableau is always consists of the coefficients of the rearranged objective function. And by rearranged, we mean we're going to move all the terms to the left-hand side and set the whole equation equal to 0. When you rearranged the coefficients and the terms in an objective function, those rearranged coefficients are going to be, some of them are going to be negative, one or more. So, and the leftmost negative number in the objective row, which is at the bottom of the initial simplex tableau, that leftmost negative number defines where the pivot column is. And the pivot column is the column of numbers right above that leftmost negative number. That's what this is talking about. So this is very important. Once we identify the pivot column, this comes next. If all the numbers in the pivot column are either negative or 0, then the maximum problem has no solution. Okay? If that's the case, so you identify the leftmost negative number in the objective row, which is at the bottom of the tableau, the leftmost negative number. That number defines where the pivot column is. Then you look in that pivot column. If all the numbers are either 0 or negative, then the maximum problem has no solution, and you stop right there. If there's only one positive, non-zero number in the pivot column, is the pivot element. Is the pivot element, and must be converted to 1. Okay, so let's first understand what this means before we go to the next step. So for in part B, we said that once you identify the pivot column, if all the numbers in that column are either 0 or negative, then you stop and write down there's no solution for the maximum problem. But it's possible that only one of those numbers is a positive non-zero number. If there is only one such number in the pivot column, you already take that as the pivot element. Remember, a lot of people make this error that they remember the Gauss-Jordan method that we've already gone through, and they think that the method here is obtaining diagonal ones as pivot elements. That was Gauss-Jordan. There are parts of the Gauss-Jordan method, a substantial part of it, that we use here. But identifying the pivot elements in the simplex method is very, very different than how we looked at pivot elements in the Gauss-Jordan method. In the Gauss-Jordan method, pivot elements were diagonals that we would convert to 1 and all the other numbers in that same column to 0. Remember that? But here, there's a different procedure to identify the pivot element. Once we identify the pivot element, then that number should be converted to 1, and the other numbers in that column should be converted to 0. But the procedure to identify the pivot element is very different than the Gauss-Jordan method. Okay, please remember that. And these two should not be mixed with each other. Now, this is if there is only one positive non-zero. What if we have multiple positive non-zero numbers in the pivot column? Then how do we decide which one of those positive numbers is the pivot element? Let's talk about that. That would be part D. So if there are two or more positive, I should write this with red ink, positive non-zero numbers. In the pivot column, okay? So if we have more than one or two or more positive numbers in the pivot column, then how do we define or how do we find which one is the pivot element? This is how. We will divide the number in the right-hand side column by the corresponding number in the pivot in the same row in the pivot column, and find, and we do this for all the positive numbers in the pivot column, and find out which of these ratios is the smallest. The smallest ratio will tell us which one of those positive numbers in the pivot column is the pivot element. And why is this important? Well, because that number we identify as the pivot element must be converted to 1. That is, if it's not already 1. If it's 1 already, then we leave it like that. But if it's not 1, we will convert it to 1, and all the other numbers in that column should be converted to 0. By the way, the same way as with the Gauss-Jordan method, the row that contains the pivot element. So we go through this procedure, we find the smallest ratio, and we identify the number that is going to be the pivot element. Now, the row that contains that number, it's going to be our pivot row. Remember what we use the pivot rows for from Gauss-Jordan method? It works the same way here. We will use the pivot row to convert the other numbers in that pivot column to 0. So next, I'm going to do a note that is associated with this part D. So on the next page, because I've run out of space here, on the next page there's going to be a note. That note is associated with part D here. Okay, so this is a very important note. So if you calculate the ratios and you find that there are 2 or more ratios that are smallest ratios, but they're equal to each other, then whichever of the positive numbers in the pivot column that led to these smallest ratios can be taken as the pivot element. So you can convert either 1 to 1, and the other numbers in that pivot column equal to 0. Okay, so we're close to wrapping up all these descriptions, and that's nice because then we can start looking at examples. the final tableau. So this is a question. This Q means this is a question. The final tableau So how do we know as we go through this procedure, pivot row operations, that we are done? We are done when all the numbers in the objective row, which is at the very bottom of the tableau, are going to be, all the negative numbers are gone and all we have are positive numbers. That's when we know we have reached the final tableau. So having said that, how do we find the solution of the maximum problem? Once we're at that stage, how do we find the solution of the maximum problem from the final tableau? So this is how we will do that. I should add here, if the numbers are all zeros, and let me add here a single one, not that zeros and multiple ones. There could be multiple zeros, but not multiple ones. If there's zeros and a single one, then Okay, so once we have the final tableau, we're going to look at the numbers under each non-basic variable, right? Remember, across the top, if I search for my initial simplex tableau, remember this initial simplex tableau where you have the p non-basic variables and then slack variables? Right now, because this is the initial simplex tableau, we have negatives in the objective row. But when we reach final tableau, there's not going to be any negative numbers in this objective row. They're all going to be positive. Once we have the final tableau, we look at the non-basic variables for the maximum problem. For the minimum problem, we look at these two, not here. For the maximum problem, we look at these two non-basic variables and what we have under them. If these numbers under the non-basic variables are either 0 and 1, with only 1 in that column, then the right-hand side column has the value of that non-basic variable in the same row as the 1. Not the zeros, in the same row as the 1. So suppose if I had a 1 in my final tableau, I have a 1 here and a 55 here. Then the value of x1 would be 55. Okay, that's what we're talking about. Suppose in the final tableau, we have other numbers under any non-basic variable, other numbers than zeros and a single 1. If that's the situation, then the value of that non-basic variable in the maximum problem is going to be equal to 0. So if they're just zeros and a single 1, the value of that non-basic variable in the maximum problem is found by looking in the right-hand side column, right where the 1 is located, not where the zeros are. And if we have other numbers under any non-basic variable, then the value of that non-basic variable in the maximum problem is going to be 0. I'm just repeating this to give you a strong reminder or a strong previous knowledge before we actually do the examples. But if you're still thinking about how this is going to work, don't worry about it. When we get to examples, this will all be very clear. Okay, so let's move. Finally, we are done with all the descriptions, and now we can talk about some examples. Recall that the beginning of the simplex method is with the initial simplex tableau, right? So for the next at least couple of examples, all we're going to do is look at a maximum problem, a standard maximum problem, and set up the initial simplex tableau. We really have to know this part very, very well, because if our initial simplex tableau is not correct, then everything else we do after that is not going to matter. It's going to lead to an error somewhere down the road. It's going to waste our time. So let's make sure we know exactly how to set up an initial simplex tableau. So that's all we're doing. We're setting up the initial simplex tableau without solving the maximum problem. And here is the maximum problem. We want to maximize Okay, first of all, note that this is a standard maximum problem, right? So we have all the variables x1, x2, x3 positive. They're all greater than or equal to 0. We have all three constraint inequalities being less than or equal to a positive constant. So both conditions for having a standard maximum problem are met. You need to know this for this course. What consists of a standard maximum problem? You need to know about those two conditions. It will come up in exams, or there's a strong likelihood that it will come up in the exams as a multiple choice question. Okay, so to set up the initial simplex tableau, let's begin with I'll use my red ink with the objective variable p, and then we have three non-basic variables, right? So let's write those down: x1, x2, x3, and then we're going to have three. We have three constraint inequalities. We need one slack variable to convert each of these to an equality. In other words, what I'm talking about is, so for here, we need to convert this inequality to equality. Otherwise, we won't be able to use these coefficients in our matrix. So we don't need to do that for the objective function, of course, because it's already an equality. So now for the first constraint inequality, we have 3x1 plus x2 plus x3 plus s1 equals, right, 30. Compare that with that. We introduced the slack variable 1 and converted this inequality to an equality. Let's do the same thing here. 5x1 plus 2x2 plus x3 plus s2 equals 24. And this one, we have x1 plus x2 plus 4x3 plus s3 equals 20, right? So now, in addition to x1, x2, x3, we have these three slack variables. So therefore, s1, s2, s3, and of course, finally, the right-hand side column. And like this, and I'm going to, you don't need to put you see me put this vertical and this horizontal line in all of my tableaus. These are just as a visual aid. If you don't like to include the vertical and the horizontal, it's totally fine. I just prefer to use them as a visual aid. Okay, so now that we have all the variables across the top and the right-hand side column, let's use these numbers to create our initial simplex tableau. Let me, I'm not sure if I should do it now or at later, but I guess I can do it now. It doesn't make any difference. So we introduced the slack variables. Now we're ready to import these coefficients into the tableau. But for the maximum problem, we need to, remember from the descriptions, we need to move all these terms to the left and set this original objective function equal to 0. It's not these coefficients that we should enter into the simplex tableau. It's the rearranged coefficients that we need to import. So what do I mean? I mean, let me rearrange this. We're going to have p minus 3x1 minus 2x2 minus x3. Notice I moved everything to one side, to the left, with p, then equals 0. These are the coefficients we're going to import into the initial simplex tableau, not the original ones. And this is also in the description that I gave minutes ago. Okay, so now we're ready to write our initial simplex tableau. The top rows, remember the top rows are the coefficients of the constraint equalities. So in the first constraint equality, there is no p, right? So the coefficient is going to be 0. There is an x1, and the coefficient of that is 3. There is an x2, and the coefficient is 1. There is an x3, the coefficient is 1. There is s1, and the coefficient is 1. There is no s2 or s3, so 0, 0. And the right-hand side gets the constant, 30. Okay? Think about what just happened. Pause the video and write down on your own, on a piece of paper, the other numbers for the other 2 rows. There's going to be 2 rows above this horizontal line. Pause the video, write down those numbers, then come back to the video and see what numbers I have. Okay, so I'm assuming that you've done that and you already have the numbers. So I'm going to write my numbers down. So in the second constraint, there is no p, so the coefficient is going to be 0. There is a x1 with coefficient 5, right? Each column represents a non-basic variable so far. There's an x2, the coefficient is 2. There's x3, the coefficient is 1. There is s2, but no s1. So 0 for s1. There's s2 with coefficient 1. And then there is no s3, so 0 again. And the constant is 24. The third row is going to be the coefficients of the third constraint inequality. So there is no p here, so 0 will be the coefficient of p in that equation. There is an x1, coefficient is going to be 1. There is x2, coefficient is 1. There is x3, coefficient is 4, right? x3 coefficient 4. There is no s1 in this equation, so 0. There is no s2 in that equation, so 0. There is an s3 with coefficient 1, so 1, and the constant is going to be on the other side. Okay, so we're done with the top rows. The bottom row is always the coefficients of the objective function. The rearranged one, right? These ones. These are the coefficients we're going to import, not the original coefficients. So P has coefficient 1, so 1, right? X1 has coefficient -3, -3. X2 has coefficient -2, -2. X3 has coefficient -1, -1. There is no slack variables here, right? Because it was an equality to begin with. We never needed any slack variables for the objective function. So 0, 0, 0. And then the other side is, of course, 0 as well. So this is the initial simplex tableau. This is very, very critical that you know how to set up correctly. Like I said earlier, if this is wrong, the rest of the solution is not going to matter much. Okay, so let's do another example just to be sure that we know how to set up this initial simplex tableau. And let me quickly add that we do not wish to solve this. Okay, so here's the maximum problem. We want to maximize this objective function subject to these constraints. We have 2x1 plus x2 less than or equal to 10, 3x1 plus x2 plus x3 plus 2x4 less than or equal to 18. And of course the condition for a standard maximum problems. Okay, so let's just, before we answer this question, let's quickly check to see if this maximum problem is a standard maximum problem. First of all three variables that are here, well, there's also another one. So let me add x4 also greater than or equal to 0. All three non-basic variables are positive, and each of the constraint inequalities is less than or equal to a positive constant. So yes, this is a standard maximum problem. So at this point, before I write down my initial simplex tableau, it would be really good if you could pause the video, write down the initial simplex tableau for this on your own paper, and then come back to the video and see if your answer agrees with my initial simplex tableau. Okay, I'm assuming you've done that and you're back. So we have the P, we have 4 non-basic variables, so x1, x2, x3, x4. We have 3 constraint inequalities, so we need one slack variable to convert each one to an equality. So we have S1, S2, S3, and of course the other side is the right-hand side column. Okay, so here is our box to enter all the numbers. and p here. All right, first of all, in the top rows, we're going to have these coefficients for the constraint equality, right? So we don't have any p variable anywhere here. So all of these under the p variable, we're going to have 0, 0, 0. And for the objective row, we always have the 1 because we have a p in the objective function. Okay, so let's grab each of these numbers. So for x1, we have a 2. For x2, we have 1. For x3, there is no x3, so 0. There is no x4, so 0. Now for s1, we're going to need an s1 to convert this to an equality, right? I don't want to write it down because you should now start doing these things in your head rather than writing things down. It's quicker, it's more efficient during an exam. So there is going to be an s1 here to convert this to an equation, and the coefficient of that is going to be 1. There's not going to be any s2 and s3 for this inequality, so 0, 0, and then 10. Okay, I hope you followed that. If not, please don't hesitate to ask your questions on the discussion board. All right, so for the second constraint inequality, we have an x1. We already know there's no p there, so 0 here. There is an x1, so 3 coefficient. There is x2 with 1 coefficient. There is an x3 with coefficient 1. There is an x4 with coefficient 2. Is there going to be s1 here? No. S1 was already used up to convert this inequality into an equality. So for this one, we're going to have an S2. So for S1, it's going to be 0. For S2, it's going to be 1. There is not going to be any S3 in this one, right? So 0 again, and the constant on the other side is 18. So the last inequality, there is no p in here. So here is 0 for p as the coefficient for p. For x1, coefficient is 1, right? I'm looking at these columns. x2 has coefficient 1. x3 has coefficient 1. x4 has coefficient 1. Is there going to be s1 here? No. s1 was already used up here. So it's going to have a 0 coefficient here. Is there going to be s2 here? No. S2 was used in the other upper inequality, so 0 again. Is there going to be S3? Yes. S3 is needed to convert this inequality into an equation, so with coefficient 1, and of course the constant 14. So we're done with the coefficients of constraint inequalities. Now we need to import the coefficients of the objective function. But remember, please, that we're not going to import these coefficients as they are. We're going to need to convert them. So to convert them, we're going to have p move everything to the left, right? So minus x1, minus 4x2, minus 3x3, minus x4 equals 0. So these rearranged coefficients are the ones we're going to import. So minus 1. So for p, it's positive 1. There it is. For x1 is negative 1. For x2 is negative 4. For x3 is negative 3. For x4 is negative 1. And there's not going to be a slack variable, so 0, 0, 0 in the objective function. We do not have a slack variables. And of course, the other side is 0, which will be here. Well, here is a maximum problem that we're going to take from start to finish. We talked about how to get the simplex method, initial simplex tableau. Now we're going to finish this problem from start to finish. So here, the first thing for us to do is simply set up the initial simplex tableau. So we have the P, x1, x2, s1, and s2, right? So we're going to have two slack variables, one for each of the constraint inequalities, and of course then the right-hand side column and the objective row. So the first column is always 0, 0, 1 because there is no p variable in any of these constraint inequalities, so the coefficient would be 0. And in the objective row, which takes the coefficient of the objective function, the coefficient of p is 1, and there we have it. So one more thing before I import those coefficients into this initial simplex tableau is first, as we said before, let's rearrange these terms in the objective function. So I'm going to move everything to the left and set it equal to 0. So p minus x1 minus 5x2 equals 0, right? Move everything to the left and set it equal to 0. Now these coefficients are ready for import into the initial simplex tableau. So for x1, we have 2. For x2, coefficient is 1. For s1, that's the first constraint inequality that we're converting to an equality, so that gets 1. S1 goes with the first inequality, and then S2 gets 0 coefficient because there's no S2 in that first inequality. Because remember, the S1 is basically coming from here. Let's rewrite this. We have 2x1 plus x2 plus s1 equals 10. So that s1 converts the inequality into equality. But there's no s2, so the coefficient in the first constraint inequality gets to be 0. Now the right-hand side is, of course, 10. Now from the second constraint inequality, the coefficients are 1 for x1. Right underneath x1, we have 1. For x2, it's 2. That's underneath x2. And we have to convert this to an inequality, so that will be x1 plus 2x2 plus s2 equals 10, right? So we have s2 here, but no s1. Because there's no s1, the coefficient of s1 in the initial simplex tableau becomes 0. And then for s2, we have 1, right? That's the coefficient of s2. And then the right-hand side, we have 10. Now, in the objective row, we need to import the coefficients of the rearranged objective function. Not the original objective function, but the rearranged one, this one. So P already has coefficient 1, which is there. X1, that's this column, has coefficient -1. X2 has coefficient -5. And there are no S1 or S2 in the objective function because there is no need for them, right? This is already an equality. We don't need to convert it to another equality, right? So it doesn't get any slack variable. That's why it always gets the 0. And of course, 0, that's this 0 on the far right-hand side that ends up here. Okay, so as we talked about, the first negative number in the objective row, the first negative number from the left determines the pivot column. So our pivot column is this one. This is our pivot column. Now, one of these two numbers, either 2 or 1, is the pivot element. So we have to find out which one. To do that, we need to find the smallest coefficient. So 10 divided, this number in the right-hand side, divided by 2, we get 5. And 10 divided by 1, we get 10. And this 5 is the smallest ratio, right? So this is the smallest ratio. Therefore, this 2 is the pivot element. So what does that mean? That means we need to convert this 2 to 1. And how are we going to be able to do that? Well, all we need to do is multiply the first row by 1/2. Even though it's just this number that we need to convert to 1, we can't just multiply this number by 1/2. We have to multiply the whole row by 1/2. So then we have, this is the row operation we need to implement. It's row 1 is equal to 1/2 times row 1. Okay, so let's do that. Move this up a little bit. Okay. So we have once again P, X1, X2, S1, S2, and of course the RHS, or the right-hand side column, and the objective row that's going to be here. So we're multiplying that whole first row by 1/2. This whole row by 1/2. Okay. So 1/2 times 0, 0. We're just doing this row operation. 1/2 times 2, 1. 1/2 times 1, 1/2. 1/2 times 1, 1/2 again. 1/2 times 0, 0. 1/2 times 10, it's going to be 5. Now, the second and the third row do not change for now. So let's write them down as they are. So 0, 1, and 2, 0, 1, and 10. And of course, the 1, -1, -5, 0, 0, 0. Okay, so this is our pivot element. Now, which row do you think is the pivot row at this point? Well, the same row that contains the pivot element is the pivot row. So the pivot row is this one, because it contains the pivot element. So let's write that down. This is the pivot row. Why is this important? Because in order to convert the other numbers in the pivot column to 0, that means these numbers, in order for us to convert the 1 and this -1 to 0, we need to use the pivot row. So in both of those row operations, we need to involve the pivot row. And remember, we're always going to add to the row that we're changing. Always add. Do not subtract, because it causes problems. If you forget to distribute the negative to a number, it's gonna destroy the whole rest of your solution. So always add in order to minimize the possibility of making an error. Okay, so how are we going to get this 1 in this pivot column to be 0? All we need is a -1 to add to this one to get it to be 0, right? So where is the -1 going to come from? It's going to come from multiplying the pivot row by -1 and then adding it to the second row. So row 2, because row 2 is the row we're changing, right? We want to make this 1 equal to 0. And that 1 is in row 2. So we're changing row 2. So row 2 is equal to -1 times row 1 plus row 2. So notice I'm adding to the row that I'm changing. So how are we going to get this -1 to be 0? Well, all we need is a +1 to add to this to make it 0. Where is the 1 going to come from? It's going to come from this pivot row. So all we need, we're changing row 3, right? This -1 is in the 3rd row. So row 3 is equal to row 1, which is the pivot row, plus row 3. Okay, we're always adding the pivot row to the row we're changing. Okay, all right. So let's write down the next tableau. I strongly encourage you to please pause the video at this point, write down the next tableau, and then unpause the video to compare your next tableau with mine. Okay, that way you learn the fastest and the best way. Okay, so I'm assuming you've done that, and now you're back. So P, X1, I'm just going to rewrite those variables on top, like that. So the first row isn't changing because that's the pivot row, so I'm going to write it as it is. The second row is going to change according to this row operation. -1 times the first row, plus the second row, which is row 2. So -1 times 0 is 0. 0 plus 0, 0. -1 times 1, -1. Plus 1, 0. Right? We're carrying out this row operation, this one. -1 times 1/2 is -1/2. Plus +2, it's +3/2. These are small, easy fractions to handle. So no worries here. Okay, so -1 times 1/2 is -1/2. Plus 0, -1/2. -1 times 0 is 0. Plus 1 is 1. -1 times 5 is -5. Plus 10 is +5. Right? So then, of course, we're going to have the objective row. So objective row is going to be here. Okay, so how is that going to change? Well, according to this row operation, row 3 is equal to row 1 plus row 3. So 0 plus 1, 1. Right? We're just carrying out this row operation. 1 plus -1, 0. And that's good because that's what we intended, right? Our pivot element still is here. And the numbers in the pivot column are becoming 0 and 0, which is what we needed. And then 1/2 plus -5, that's going to be -9/2, right? So we can do that as a common denominator here. So we're simply doing 1/2 plus -5. So 1/2, so 1/2 plus 1/2 plus -5, right? -5. So the common denominator is 2. It's going to be 1 minus 10. So we end up with -9/2. That -9/2 ends up here. So -9/2. And then 1/2 plus 0. We're still carrying out this row operation. 1/2 plus 0, because row 1 plus row 3. 1/2 plus 0 is 1/2. 0 plus 0 is 0. And 5 plus 0 is 5. Okay? I hope this matches what you wrote down for your next tableau before you pause the video, or before you unpause the video. Okay? All right. So what do you think? Are we done? We're not done, right? Because we still have this negative number in the objective row. Whenever we end up with all positive digits here, then we're done. But this is not the final tableau yet. So we need to keep going. Okay, so our pivot column is going to be this. This is our pivot column. Both numbers are positive. So what that means is we need to find the ratio for each one. If you had just if one of these was negative and the other one was positive, then the positive number in the pivot column would automatically be the pivot element, which would mean we would convert that number to 1. But in this case, they're both positive, so we need to find the smallest ratio. Okay, so let's do that. So we have 5 divided by 1/2, that's 10, and 5 divided by 3/2. And that's going to be 10 over 3. And so 10 over 3 is the smallest ratio than 10, right? So this is the smallest ratio, which means we need to convert this 3/2 to 1. That's our pivot element. We need to convert this to 1. Okay. So let's see how are we going to do that. Well, the row operation for converting this 3/2 to 1 is multiply that whole row by 2 over 3, right? So this whole row we need to convert. We need to convert that 3/2 to 1. And to do that, we're going to multiply. This is the row operation. That 3/2 is in the second row. So row 2 is equal to 2 over 3 times row 2. If you do that, you're going to get 1 there, which is what we need. And then the 1/2 and minus 9 over 2 need to be converted to zeros. Okay, so before you see I'm going to write down the next tableau, but before you see that, please make sure that you pause the video and write down your own solution for the next tableau, and then compare that with my work. Okay. All right, so I'm assuming you've done that. And so let me write down my tableau here. So we'll have the P, X1, X2, S1, S2, and the right-hand side column. And there's the dividing line for the objective row. Okay, so all we're doing, we're changing the second row, right? So the first row stays as it was, 0, 1, 1/2, 1/2, 0, 5. And I want to make sure that you can follow this. So I wrote down, so there it is. I just wrote down this row because it's not changing. Now this row is changing according to this row operation. So 2/3 multiplied by that whole row. So 2/3 times 0, 0. 2/3 times 0, 0 again. 2/3 times 3/2, that's 1, which we intended. So we got our pivot element to convert to 1. 2/3 times minus 1/2, that's minus 1/3. Right? After simplifying, we get minus 1/3. 2/3 times 1 is 2/3. 2/3 times 5, it's 10 over 3. And of course, the objective row stays the same. Like that. 5. Okay. All right, so now we've got to convert, because this being our pivot element, pivot column, this is our pivot column right here. So we already got the pivot element convert to 1. We need to make these two numbers, 1/2 and minus 9 over 2, converted to zeros. Okay, so which row now is our pivot row? Well, if you answered the second row, you are correct. This is our pivot row. Why is that? Because that row contains the pivot element. So this is the pivot row. That's important. Why? Because it means in order to convert the 1/2 and minus 9/2 to 0, we're going to need to use the pivot row. So 1/2 is in row 1. Row 1 is equal to, how are we going to get a 0 in that spot? All we need is add a negative 1/2 to it. Okay, but where's the negative 1/2 going to come from? It's going to come from multiplying the second row by negative 1/2 and adding it to that first row. So minus 1/2 times row 2, which is our pivot row, plus row 1. Notice we always add to the row we're changing. Okay, so how are we going to get this minus 9/2 to become 0? All we need is to add a positive 9/2 to this. Fine, but where's the 9/2 going to come from? It's going to come from multiplying the pivot row by 9/2 and adding it to the minus 9/2. So row 3, because we're changing, as we convert this to 0, we're changing the entire row 3. So row 3 is equal to positive 9/2 times row 2 plus the row we're changing, which is row 3. Okay. Okay, now, before you see my next tableau, I'm asking you guys to please pause the video, write down the next tableau according to these row operations, then compare your tableau with my next tableau. Okay? All right, so let's do that. Well, I'm assuming you've done that, and now you're back. All right, so hopefully our answers agree. Like that. First, we're going to work with this row operation, this one, right, to change the row 1 according to this operation. So minus 1/2 times row 2 plus row 1. Minus 1/2 times 0 is 0, plus 0, 0. Minus 1/2 times 0, which is in row 2, 0 again, plus 1, 1. Minus 1/2 times 1 is minus 1/2. Right? Minus 1/2 times 1 is minus 1/2, plus 1/2, it is 0. Minus 1/2 times minus 1/3, that's positive 1/6. Positive 1/6 plus 1/2. What do we get? Let's see. So positive 1/6, right? Minus 1/2 times minus 1/3, it's going to give us 1/6. Plus 1/2. So take the common denominator, which is 6, and we end up with 1 plus 3. So that's 4/6, or 2/3. Right? So we're going to get 2/3 under this spot, under S1. So 2/3, which is minus 1/2 times row 2 plus row 1. That's what we got. Okay, so let's continue. Minus 1/2 times 2/3, it's minus 1/3. Minus 1/3 plus 0, it's minus 1/3. So minus 1/2 times 10/3, that's minus 10/6, or minus, after simplifying, I'm multiplying minus 1/2 by 10/3, which is in row 2. That's what this is saying that we should do. Minus 1/2 times row 2, that in this spot, that'll be minus 10/6. Now minus 10/6, if you simplify it, right, minus 10/6, simplify that. Minus 1/2 times 10/3, it's minus 10/6, then minus 5/3. So in this spot, so minus 5/3, and then that's just this piece. Minus 1/2 times 10/3. It's going to be this. But then we have to add it to row 1. So plus 5. Minus 5/3 plus 5. Okay, so common denominator is 3. We're going to get minus 5 plus 15, and that's going to give us minus 5 plus 15 is positive 10 over 3. And that 10 over 3 goes here. Okay? So that all we did was carry this operation to this number and add it to that 5. And we ended up with 10 over 3, which goes here. The second row is the pivot row, so we're going to write it down as it is. So 0, 0, 1. So that's still our pivot element, 1. Minus 1 over 3, which is there. 2 over 3. And then 10 over 3. Now we need to change the third row according to this row operation right here. Okay, so which says multiply the second row, which I've highlighted, by 9 over 2 and add it to the third row. So 9 halves times 0 is 0, plus 1, 1. All right? 9 halves times 0, 0 again, plus 0 is 0. 9 halves times 1 is positive 9 over 2, plus minus 9 over 2 is 0 again. 9 over 2 times minus 1/3, right? 9 over 2 times minus 1/3, that would be minus 9 over 6. Simplify that, so minus 9 over 6 simplified, we get minus 3 halves. And then minus 3 halves plus positive 1 half, it's going to give us minus 1, right? Minus 3 halves plus 1 half plus 1 half, it's going to be minus 2 over 2, which is minus 1. Let me move this over a little bit so you can see it. Okay, so a lot of this is arithmetic, just carrying out the arithmetic. This negative 1 ends up here. So once again, the way we got this negative 1 is this. We're carrying out this row operation. So when we got to this point, 9 halves times minus 1 over 3, we simplified it. It's minus 9 over 6 equals minus 3 halves. Then minus 3 halves added to positive 1 half. That's what we did here. We ended up with negative 1. That's what we have here. Then let's continue to the next number. 9 halves times 2 over 3, it's 3, right? 9 halves times 2 over 3 is just 3. 3 plus 0 is 3. So just in case you have a question, let me show it here. 9 halves times 2/3. This 2 and this 2 cancel out. We end up with 9 over 3, which is 3. And that's the 3 you see here. But after we got 3, I had to add it to 0. 3 plus 0, we get 3 itself. Right? Okay. So we have one more number left here. 9 halves times 10 over 3, that's 90 over 6. Right? Let me do that here. 9 halves times 10 over 3, we get 90 over 6. 90 over 6 is equal to 15, right? So we got 15 from that, from multiplying 9 halves times that. We got the 15. But 15 then needs to get added to 5, right? We're doing this row operation. So 15 plus 5, it's going to be 20. Okay? I hope this matches the tableau that you got. Now next, let me ask you this. Are we done? We're not done, right? Because we still have a negative number in the objective row. If we had all positive numbers here, then we were done. Then we could answer the question. We could solve the system or maximize the objective function that way. But we can't. We can't stop. We need to move forward. Okay, so Therefore, our pivot column then is this one, because those numbers are above this negative number, right? The only negative number in the objective row. Now, would you have to calculate the ratio here to find the smallest ratio, to find the pivot element? No, not this time. Why? Well, because this time, of the two numbers that are above the negative number in the objective row, only one of them is positive. The other one is negative. So we're not going to take the ratio of the right-hand side with a negative number. No. That's going to create all kinds of problems. So that's not how this procedure works. So the only positive number left is the pivot element. Okay, we don't need to look for a smallest ratio. If both of these were either negative or 0, or one was 0, the other one was negative, there would be no solution for this system. So let me repeat that once again. If we have two negative numbers here, this system would have no solution. If we had a negative number like we have now and a 0 instead of 2/3, if we had a 0, again, there would be no solution. So the only way we could have a solution at this point is that if we have at least one positive number over this negative number in the objective row. And fortunately, we do have one positive number. And that positive number becomes the pivot element. So which means we're going to need to convert this 2/3 to 1. Right? So what row operation would give us that? Before you watch the next few seconds, pause the video, write down your own row operation for converting this 2/3 to 1, and then unpause the video. Okay, so I'm assuming you've done that. So to convert this to 1, we have row 1, we're changing row 1, right, is equal to 3/2 row 1. So you multiply that whole row by 3/2, you're going to get a 1 in that spot, which that's what we need. Okay, so let's do that. Again, please pause the video, write down the next tableau, then unpause the video to see my result. Okay, and I'm counting on you that you're doing that as you're watching this video. Okay, so multiplying the first row by 3/2, right? We're multiplying this whole row by 3/2. So we're going to get 3/2 times 0, 0. 3/2 times 1, 3/2. 3/2 times 0, 0. 3/2 times 2/3, 1. And that's what we needed, right? And so that's our pivot element. 3/2 times minus 1/3, right? That would be minus 1/2. So minus 1/2. 3/2 times 10/3, that'll be 5. Okay, so this whole row, now this whole row, it's going to be our pivot row. Okay. And the other two rows do not change for now, so I'm going to write them down as it is. 0, 0, 1, negative 1/3, 2/3, 10/3, 1, 0, 0, negative 1, 3, and 20. And I'm going to double check this really quickly. And so 3/2, that this minus 1/2, 2/3, 5, 10, yes, that's correct. Okay, so this is our pivot column. This is still our pivot column. We know that that yellow highlighted row is the pivot row, which is important. Why? Because that means in order to make this minus 1/3 and this minus 1 to 0, we're going to need to use the first row as our pivot row. Okay, so before you see me write down the next 2 row operations, go ahead, pause the video, write down on a piece of paper your own 2 row operations, and then come back to the video to see if your row operations match mine. Okay, all right, so I'm assuming you've done that, and now you're back. So to convert the minus 1/3 to 0, that minus 1/3 is in the second row. So row 2 is equal to, all we need is to add a positive 1/3 to this. Okay, fine, but where is the positive 1/3 going to come from? It's going to come from multiplying the first row by positive 1/3. So 1/3 times row 1, which is the pivot row, plus the row we're changing, which is row 2. So notice once again that we always add to the row that we're changing. Okay, so that's going to convert the minus 1/3 to 0. How about this minus 1? Well, that's an easy row operation, right? Because the pivot row, we got a 1. All we need is add a positive 1 to this, and we're going to get it to be 0. So row 3, which is where this negative 1 is equal to row 1 plus row 3. Okay, I hope this matches what you have on your paper. If it does, wonderful. That means you're making wonderful progress toward mastering this procedure. Okay, so please pause the video, write down, according to these row operations, write down the next tableau before you see my result. Okay, I'm assuming you've done that, and now you're back. So we have P, X1, X2, S1, S2, and the right-hand side column. The pivot row doesn't change, so I'm going to write it down as it is. 0, 3/2, 0, 1, and that 1 is our pivot element, minus 1/2, and 5. So now we're going to do this row operation together, okay? Or, well, you're done. You should be done on your paper, so actually I'm going to try to catch up with you. So 1/3 times row 1 plus row 2. 1/3 times 0, 0, plus 0, 0. 1/3 times 3/2, that's 1/2, plus 0, 1/2. 1/3 times 0 is 0, plus 1, 1. 1/3 times 1 is 1/3, plus negative 1/3 is 0, which is what we wanted to do, right? That's what this was meant to do. So we got it done. But we need to continue to finish the row, the second row. 1/3 times negative 1/2, that's minus 1/6. Minus 1/6 plus 2/3. Let's do that. Let's do that here. Minus 1/6 plus 2/3, right? So I'm still carrying out this row operation. 1/3 times 2/3, that's, let me see, no, sorry. 1/3 times minus 1/2 gave me minus 1/6, right? 1/3 times minus 1/2 is minus 1/6, and then I'm going to add it to this 2/3 plus 2/3 to see what number I need to write down here. Okay, so take the common denominator. We have negative 1 plus 4, 3/6, positive 1/2. So we're going to have that 1/2 is going to end up here, 1/2. Okay, so we have one more number to get, which would be that one. It's still blank, right? So 1/3 times 5, that's 5/3. 5/3 plus 10/3, which is, this is what this is saying, plus row 2. 5/3 plus 10/3, that's 15/3, which is 5. Okay, so we're done with this row operation. We need to carry out this one now. Okay, let's do that. And again, I'm hoping that you've already done that and you're just comparing your values with mine. Okay, so this is easy one. It says add to replace row 3, simply add row 1 to row 3 for this one. So 0 plus 1, 1. 3 halves plus 0, 3 halves. 0 plus 0, 0. 1 plus negative 1, 0. That's what we intended, right? And then minus 1 half. Minus 1 half plus 3, that's going to give us 5 over 2. 5 over 2. And that. And then 5 plus 20, 25. So are we done? We are done, right? We are done because you look at this objective row at the bottom and there's all numbers are positive. There's no negative number here. So we are done. So this is the final tableau. So this tableau here, all of this is final tableau. Okay, so this final tableau has our solution. It has the solution to the system. So where is this solution? Okay, so to obtain for the maximum problem, when we get to the minimum problem, that's different. But for the maximum problem, you look under the variables x1 and x2. Okay, look under x1. The numbers here are all over the place, right? They're different numbers than 0 and 1. Compared with these numbers, 0, 1, 0. That's what we'd like to see. But if we don't see that, if you don't see 2 zeros and a single 1 under this variable, that means the value of that variable in the maximum objective function is 0. So x1 equals 0. Once again, look under the numbers. Look at the numbers under the variable x1. There are not zeros and a 1. If they're not, then the value of that variable is going to be 0. Okay, so that's that. Now x2, you have a nice 2 zeros and a 1. Okay, good. So now the value of this variable in the objective function at maximum is in the right-hand side column right across where the 1 is. Not where the zeros are, but where the 1 is. So x2 equals 5. And then, of course, the value of the maximum value of the objective function is that. So p equals 25. So this is the solution of that maximum problem. x1 is equal to 0, x2 equals 5, p is equal to 25. So once again, because people always have questions about this, how does this x1 to be 0? Well, you have the final tableau. There are no negative numbers in the objective row. So this is how you read the solution from the final tableau for the maximum problem. For the minimum problem, it's going to be different. But for the maximum problem, this is what you do. You look under each non-basic variable. x1 and x2 are non-basic. s1 and s2 are basic variables. So the x1 and x2, under x1, the numbers are all over the place. 3 halves, 1 half, 3 halves again. So if you see numbers like all over the place like this, then the value of that variable, it doesn't matter which one of these this is. The value of that variable is going to be 0. So when is the value of these variables is not 0? Well, for that, you need to see a nice outcome like this. Zeros everywhere except in one spot, 1. If you have zeros everywhere but just 1,
then the value of that variable is going to be in the right-hand side column, right where the 1 is, across from where the 1 is. So in that case, x2 is equal to 5. And the value of the objective function at maximum is always in this corner. So p equals 25. Okay, I hope this is starting to make sense. If you pause the video like I'm asking you every step of the way, and not just copy down what I'm writing down, or not try to memorize this. Trying to memorize all of this is hopeless activity. So don't even waste your time trying to do that. This is a procedure that repeats itself over and over. What you want to do is master the procedure. And if you do that, you'll see that these are really cool, fun problems to solve. Okay? And to get there is the way I'm asking you, which is pause the video repeatedly throughout this course. If you haven't been doing it already, please start doing it right away. Pause the video, write down the next step, and then unpause the video and compare your solution with mine. For example, there is another example of solving a maximum problem using the simplex method coming up right now. So what you should do, as soon as I write down this example, you want to pause the video, take the solution all the way to the end, write down your solution of the maximum problem, then sit back and relax and compare your solution with mine. Okay, that's the way to do it. Okay, so here's the new problem. We want to maximize this objective function okay, and which is subject to these constraints. Okay, so there you have the problem, and don't worry about these constraints. These constraints x1, x2, x3 greater than or equal to 0. All that means is that that's the condition for a standard maximum problems, that the variables must be non-negative, or they must be positive. Okay, so that's just saying that, okay, we are satisfying that condition, and this is a standard maximum problem. That's all there is to it. But these are the real constraint inequalities that we are concerned with, these three. Okay, so you should pause the video at this point, take this whole problem all the way to the end, and then compare your solution with mine. Okay, so I'm assuming you've done that and you have your solution fully figured out in front of you, which is wonderful, and you're here to compare that with my result. So let me begin by saying that P, we have three non-basic variables, x1, x2, x3. So x1, x2, x3, and we have three constraint inequalities, and we're going to need one slack variable for each of these. So we're going to have S1, S2, S3, and the right-hand side column. And of course the objective row, right? So that's P there. All right. So let's import these coefficients into this initial simplex tableau. We have minus 1, right? Underneath x1, we have minus, well, first of all, let's say 0, 0, 0, 1. That's for the 3 constraint inequalities here. We need to have 3 rows, 1 row for each constraint inequality. None of them have a p variable in them. Therefore, always this first column is going to look like this. 0, 0, 0, and 1. Okay, let me move this up a little bit, like that. Okay, so we got that figured out. Now, x1, x2, x3. So the coefficient of x1 in this constraint is negative 1. The coefficient of x2 is 2. Underneath x2, we have 2. 3 for x3. Now, s1 is the slack variable to convert this first constraint inequality to an equality, right? Remember, we're going to need to, we can't import coefficients of an inequality into a matrix. We need to convert this into an equality. To do that, we're going to need the slack variable 1. So the coefficient of S1 is 1 for that one. There's not going to be any S2 and S3 there because there's no need for them. So 0, 0, and of course 6 is the number in the right-hand side column. Okay? So now let's write down the coefficients for the second row. Where are they going to come from? They're going to come from these coefficients of the second constraint inequality. Minus 1, 4, right, under x2. 5 should be under x3, right there. Is there going to be an S1 there? No, because S1 is already used up here to convert the top constraint inequality to an equality. So there's no need for S1 here. It's already used up. So we need to introduce a new slack variable, S2, so 0 here and a 1 here. Okay, so we introduce S2 to convert this second inequality to an equality. And S3 is 0. Right? There's not going to be any S3 here because there's no need for it. And then 5 is going to be in the right-hand side column. Now the last row here, we have positive 1. Positive 1 there. 5 under x2. 7 under x3. Is there going to be S1 here? No, S1 is already used up here. Is there going to be S2 here? No, S2 is already used up here. So 0 here. Is there going to be S3 here? Yes. S3 is the slack variable we need to introduce in order to convert this inequality to an equality. So 1 here, and of course 7 is in the right-hand side column. Okay? All right. So what about the objective row here? Well, the objective row, remember, I hope you didn't forget that for the objective row, we need to rearrange these, the equation, the objective function. So when we rearrange it, we have P, move everything to the left. P minus 2x1 minus 4x2 minus x3 equals 0. Okay? So it's these coefficients that we need to import into the initial simplex tableau. So P is already 1, has coefficient 1, and it's already there. For x1, minus 2. For x2, minus 4. For x3, minus 1, right? Under x1, we have minus 1. There is no need for a slack variables here because it's already an equation. It's not an inequality, so we don't need to use a slack variable. So for all the slack variables, we get 0, and of course that 0 ends up here in the right-hand side column. Okay? All right, so you already know that the pivot column is going to be this one. Right? That's the first negative number from the left, and it defines the pivot column. So out of these 3 numbers, only 1 is a positive number. So that positive number automatically becomes our pivot element. That means we do not need to calculate smallest ratio in this case. This 1 is the only positive number above the objective row, and that 1 becomes our pivot element. And that, so we don't even need to convert it to 1. Fortunately, it's already 1, right? So we don't need to do anything to this. But we need to convert the -1, -1, and -2 to zeros. Okay, that's what we need to do next. And which row is the pivot row? The third row, right? The third row is our pivot row. Why? Because it contains the pivot element. Why is that important? Because in order to get -1, -1, and -2 to 0, we need to use the pivot row, which is the third row. That's why it's important. So this is our pivot row. Okay. All right. So in order to convert -1, -1, and -2 to 0, we're going to need 3 row operations. And because I'm assuming that you've already finished this problem, I'm assuming you've already gone through that. So I'm going to write down the row operations. To convert this -1 to 0, we're going to need to change row 1 because that -1 is in row 1. So row 1 is equal to, all we need is a +1 to add to this -1. Where is the +1 going to come from? From the pivot row. Just add row 3 plus row 1, and you're going to get a 0 in that spot. By the same token, you're going to be able to do the same thing for row 2 to get a 0 in that spot. So row 2 this time is equal to row 3, which is the pivot row, plus row 2, which is the row we're changing with this row operation. And of course, finally, to change the fourth row, this -2 is in the fourth row, right? 1, 2, 3, 4. So row 4 is equal to, what do we need? We need a +2 to add to this to get it to be 0. Where's the +2 going to come from? It's going to come from multiplying the pivot row by a +2 and adding it to the -2. So twice row 3 plus row 4. That's the row operation that's going to get that done. Okay. All right, so let me move this up a little bit. Okay, so let's write down the next tableau. So we have the P, and then x1, x2, x3, s1, s2, s3, and the right-hand side column. And of course, that's the objective row P. Okay? So the first column is always 0, 0, 0, and then the 1 in the objective row, because that's the coefficient of the objective variable P. Okay? Let me move this over a little bit, like that. Okay. So we're going to carry out this row operation, this one for now. So this is saying add row 3 to row 1 in order to replace row 1. So let's do that. 0 plus 0, 0. 1 plus -1, 0. Right? We're doing this. 5 plus 2, 7. We're doing this to replace row 1. Okay? 7 plus 3, 10. 0 plus 1, 1. 0 plus 0, 0. 1 plus 0, 1. 7 plus 6, 13. Okay? So 0, 0, 7, 10, 1, 0, 1, 13. We're done with this one. Let's move over to this row operation. This is saying to replace row 2, you need to add row 3 plus row 2. Let's do that. 0 plus 0, 0. It's already there. 1 plus negative 1, right? We're adding row 3 to row 2 to replace row 2. 1 plus negative 1, 0. 5 plus 4, 9. 7 plus 5, 12. 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. 7 plus 5, 12. Okay? All right. So the third row is the pivot row. So let's write it down as it is. 1, 5, 7, 0, 0, 1, 7. Okay, so I just wrote that here. Then we're done with that row operation, so let's move to this row operation here. We need two more. This is saying we need to replace row 4 by multiplying the third row by 2 and then adding it to that row 4. So let's do that. Twice 0, that's the third row, right? 2 times 0 is 0 plus 1, 1. It's already there. 2 times 1 is 2 plus negative 2 is 0, which we wanted to do, right? We wanted to get rid of this negative 2. 2 times 5 is 10 plus negative 4, that's positive 6. 2 times 7 is 14 plus negative 1, that's positive 13. 2 times 0 is 0 plus 0 is 0. 2 times 0 is 0 plus 0 is 0. 2 times 1 is 2 plus 0 is 2. 2 times 7 is 14 plus 0 is positive 14. So, are we done? We are done, right? We are done. Because you look at the objective row, all the negative numbers, all these negative numbers are gone. Okay? So this is our final tableau. Okay? So we are ready to read the solution for this maximum problem off of this final tableau. Okay, so for x1, look under each of these non-basic variables. And this is only for maximum problem. I remind you, when in section 5.3 we get to minimum problem, it's going to be different. When you get the final tableau, for the minimum problem, 80% of the procedure is the same, but there's about 15-20% difference. So when we get to it, we'll talk about it. But for the maximum problem, when you have the final tableau, look under the non-basic variables, x1, x2, x3 in this case. Under x1, you see nothing but zeros and a single 1. It shouldn't be more than number 1 here. It should be just 1 and everything else 0. If you have that scenario, then you can read the value of that variable x1 in the right-hand side column, right where the 1 is. Right where across from 1. That's 7. So x1 equals 7. Okay? For x2, look at all these numbers. They're all over the place, right? 7, 9, 5, 6. So when those numbers are not zeros and a 1, then the value of that variable is 0. For x3, the same scenario, 10, 12, 7, 13. They're all over the place. So the value of x3 is automatically 0. And the value of the objective function at maximum is always in this corner. So p is equal to 14. So this is the solution. This is the solution of the maximum problem. x1 is 7, x2 is 0, x3 is equal to 0 with p equals 14. Can you test this? Suppose you got this during an exam and you wanted to test to see if you have the right solution here. Can you test it? Absolutely. And you can do it very, very easily. How? Well, this is how. Remember that the original function, the original objective function was this. P equals 2x1 plus 4x2. Let me move this up a little bit. 4x2 plus x3, right? This was our original objective function. So just plug in these values to see if you get a valid equation, a valid result. So p is equal to 14. 2 times x1, x1 was 7, plus 4 times x2, 0, plus x3, which was 0. So for all of this drops out, you get 14 equals 14, and it checks out. So it didn't even take 30 seconds, and we were able to test that result in the objective function. Okay, so that's that. Let's do another problem, another example. So here we have an example where we want to maximize this objective function. And subject to these constraints. And of course, we have that condition where all these variables must be positive, right? Or non-negative, as your book calls it. So this is just to satisfy the fact that this is a standard maximum problem. And these two constraint inequalities, though, are the ones that we mainly need to be concerned about. Okay? All right. So here you have the full problem in front of you. So at this point, you should pause the video, take this problem all the way to the end, and then compare your solution with mine. Okay? So that's what I strongly recommend that you do. Okay, so I'm assuming you've done that. You spend 15, 20 minutes, you got your solution now, and now you're ready to compare your solution with mine. That's wonderful. Okay, so the first thing I'm going to do is just write down the initial simplex tableau. So we're going to have P, and then we have 4 non-basic variables, x1, x2, x3, x4. We got 2 constraint inequalities, so we're going to need 2 slack variables, s1 and s2, and of course the right-hand side column here. Okay, like that, and the objective row at the bottom. Okay, all right, so the first column here is 0, 0, 1. And the first row gets these coefficients, so 2, 4, 5, 6. S1 gets to convert the first constraint inequality to an equality, so 1 and then 0 here, and 24 ends up in the right-hand side column. The second row gets these coefficients, so 4, 4, 2, 2. For S1 it gets a 0. We're going to need a S2 slack variable to convert this inequality to equality, and then 4 ends up here. Okay? And of course the objective row, well, I hope you remember that we need to for the maximum problem here, we need to rearrange these coefficients, move everything to the left, so we end up with P minus x1 minus 2x2 positive x3 minus 3x4 equals 0, right? I moved everything to the left with P. The algebraic signs changed for these, and set the whole thing equal to 0. So these are the coefficients now we need to enter here. So P has coefficient 1, right there, 1. For x1, negative 1. For x2, negative 2. For x3, it's 1, positive 1, right? For x4, it's negative 3. And there is no S1 or S2 because there's no need for them, right? This is already an equation. So 0, 0, and then that's 0. That 0 ends up in the right-hand side column. Okay, so of course this first column, not the first column, but the column over the first negative number from the left is the pivot column, right there. So both those numbers are positive, which means we need to find the smallest ratio. So 24 divided by 2, that's 12. 4 divided by 4, that's 1, right? So clearly this is the smallest ratio. So that means this 4 is going to be the pivot element. All right, that one. So we need a row operation to convert the pivot element to 1. Okay, so I'm sure you know which row operation that would be. That would be row 2 is equal to 1 over 4 times row 2. Right? Okay, so let's do that. Let's write down the next. I'm assuming that you've already done this, so I'm going to do it. So P, x1, x2, x3, x4, s1, s2, right-hand side column, and P. And so so this is going to be our pivot row, this row, right? That one. And we need to convert that to 1, that 4 to 1. Okay, so for now, I'm going to write down row 1 and row 3 as they are. So 0, 2, 4, 5, 6, 1, 0, 24. Now we're multiplying that whole row 2 by 1 over 4. So 1 over 4 times 0, 0. 1 over 4 times 4, 1. And this is our pivot element right there. 1 over 4 times 4, 1. 1 over 4 times 2, 1 half. Right? 1 half here. And 1 over 4 times 2, again, 1 half. 1 over 4 times 0, 0. 1 over 4 times 1, 1 over 4. 1 over 4 times 4, 1. Okay. Okay. So now, the third row, and that, let me write that down as it is. 1, negative 1, negative 2, 1, negative 3, 0, 0, and 0. Okay, and this is our pivot column. That one, right? Okay, so now that we have the pivot element converted to 1, let me just highlight the pivot row. We know that that second row is the pivot row. Let me mark it like that. And this is pivot row. And we know why it's important, right? Because we're going to need to use the second row to convert the 2 and negative 1 in the pivot column to 0, right? Okay, so let's write down the row operation for each one. To convert the 2 to 0, all we need is add a negative 2 to it. Okay, so where is the negative 2 going to come from? It's going to come from multiplying the pivot row by negative 2 and adding it to that 2. So row 1, because we're going to change row 1, right? We're going to change 2 in row 1 to 0. So row 1, is equal to minus twice row 2, that's the pivot row, minus 2 times all of that, plus the row we're changing, which is row 1. Okay, so that's that. Then to change this negative 1 to 0, all we need is a positive 1, so we can add it to this negative 1 and get a 0. Okay, fine, but where is the positive 1 going to come from? It's going to come from the pivot row. It's right there. So we're going to say, to change row 3, all we need is add row 2 to row 3. Row 2 plus row 3. Right? So our objective is to convert this negative 1 to 0. But we can't just add these two numbers and not do the same thing to both rows. That's the whole point. That's why we have these row operations. Okay? Even though our objective is just that, to convert this to 0, we have to carry this operation out on everything, on both rows. Okay, so these are our row operations. Let's write down, well, your tableau is already written, so hopefully my answer will match what you already have on your paper. Okay, so let's carry out this row operation first, this one. So this is saying to replace row 1, multiply the second row by negative 2, and then add it to row 1. So let's do that. Minus 2 times 0 is 0, plus 0, 0. Minus 2 times 1 is minus 2, plus 2, 0. Minus 2 times 1 is minus 2, plus positive 4 is 2. Minus 2 times 1/2 is minus 1. Minus 1 plus 5 is positive 4. Minus 2 times 1/2 is minus 1. Plus 6, positive 5. Minus 2 times 0 is 0. Plus 1, 1. Minus 2 times 1/4, it's minus 1/2. Plus 0, minus 1/2. Minus 2 times 1 is minus 2. Plus 24 is positive 22. Okay, so we're done with the first row. The second row is the pivot row, so let's write it down as it is. Like that. Now we need to, so we're done with this row operation. Now we move over to this row operation. This is saying to replace row 3, add row 2 to row 3. So let's do that. 0 plus 1, 1. 1 plus negative 1, 0. 1 plus negative 2, negative 1. 1/2 plus 1, both positive, so we end up with 3 halves. 1/2 plus negative 3, right? So that's minus 2.5, which is minus 5 over 2. 1 plus 0, let's see, so 0 plus 0 is 0. 1/4 plus 0 is 1/4. 1 plus 0 is 1. Okay, so I'm just going to double check very quickly. Yep. Okay, so now are we done? No, we're not done, right? We're far, far from it because we have two negative numbers in the objective row. Okay, so the one in the leftmost column identifies our pivot column. So our pivot element is in this column. Well, both numbers above negative 1 are positive. That means we need to find the smallest ratio. So let's do that. 22 divided by 2 is 11. 1 divided by 1 is 1. Clearly, this is the smallest ratio. Which means this 1 is going to be our pivot element. And it's already 1. So it saves us one operation, one row operation. We don't have to do anything to this. We can simply convert the 2 and negative 1 to 0. Okay, so now the row operation for accomplishing that are as follows. So this is this second row is still our pivot row, that one. Okay. All right. So to convert this 2 to 0, all we need is add a negative 2 to it. Okay, so where is the negative 2 going to come from? The negative 2 is going to come from multiplying the pivot row by negative 2 and then adding it to row 1. So let's write down the row operation for that. Row 1, because 2 is in row 1, so we're changing row 1. Row 1 is equal to minus 2 times row 2 plus row 1. So that operation is going to help us to convert this 2 to 0. Okay? So we're going to need a row operation to convert this negative 1 to 0. Okay? Negative 1 is in the third row, right? So row 3 is equal to row 2 plus row 3. Simply add row 2 to row 3, right? Because all we need is a positive 1 to add to this negative 1 to make it 0. And that's how we're going to get it. Okay. So I'm assuming you've done that. I hope you finished this problem all the way to the end. I'm going to carry these row operations to write down the next tableau. Okay. Let me make sure that everything is on the screen here. Now that should be good. All right. So we have P, X1, X2, X1, X4, S1, S2, and the right-hand side column. Okay, so the first column is always 0, 0, and 1. Let's write it down. So let's carry out this row operation first, right? So we're going to replace row 1, to replace that row 1, we're going to multiply the second row by negative 2, that's our pivot row, and add it to row 1. So minus 2 times 0 is 0 plus 0, 0. Minus 2 times 1 is minus 2, plus 0, minus 2. Minus 2 times 1 is minus 2, plus 2, 0. Minus 2 times 1 half is minus 1, plus positive 4 is positive 3. Minus 2 times 1 half is minus 1, plus positive 5 is positive 4. Minus 2 times 0 is 0, plus 1 is 1. Minus 2 times 1/4 is minus 1 over 2. Minus 1 over 2 plus minus 1 over 2 is minus 1. Minus 2 times 1 is minus 2. Plus 22, we get positive 20. The second row is the pivot row, so let's write it down as it is. And this is our pivot element right here. Okay, so now we're going to carry out this row operation. We're done with that one. Okay, this is saying simply to replace row 3, add row 2 and row 3. So row 2 and row 3. 0 plus 1, 1. We already got it. 1 plus 0, 1. 1 plus negative 1, 0. 1 half plus 3 halves, that's 2, right? That's 4 over 2, which is 2. 1 half plus minus 5 over 2, that's minus 2. And 0 plus 0 is 0. 1/4 plus 1/4, that's 2 over 4, which is 1 over 2. 1 plus 1 is 2. Okay. So let me make sure that I'm just double checking to make sure everything looks good. These all look good. And yes, these look good and accurate. Okay, so are we done? Not really, right? Because we have this negative number still left in the objective row. So this is our pivot column. Now, in that pivot column, both numbers are positive. So we need to investigate the smallest ratio. So 20 divided by 4, 1 divided by 1/2. Clearly, this 2 is the smallest ratio. Okay, so that means we need to convert this 1/2 to 1. Right? So this 1/2 needs to be converted to 1. The operation to accomplishing that is very easy. Simply multiply row 2 by 2. To replace row 2, multiply that row 2 by 2. Okay, so let's write down the next tableau. The other rows stay the same. That's all we're doing for this tableau. So 0, -2, 0, 3. Okay, so let's multiply row 2 by 2. 2 times 0, 0. 2 times 1, 2. 2 times 1, 2. 2 times 1/2, 1. 2 times 1/2 again, 1 again. And that's our pivot element. 2 times 0 is 0. 2 times 1/4 is 1/2. 2 times 1 is 2. The third row stays as it was. Okay, so just a reminder that this second row is our pivot row. That's our pivot row. And then this is our pivot column. Okay, so we need to convert the 4 and -2 to 0, right? So let's write down the row operations for accomplishing that. First, this one. 4 is in row 1, right? So row 1 is equal to. How are we going to get 4 to be 0? Well, all we need is add a -4 to this. Okay, fine, but where is the -4 going to come from? Negative 4 is going to come from multiplying the pivot row by negative 4 and adding it to the first row. So negative 4 times row 2 plus row 1, which is the row we're changing. Right? So then we need to convert this negative 2 to 0. Well, how is that going to happen? Well, all we need is add a positive 2 to this negative 2. So where's the positive 2 going to come from? It's going to come from multiplying the pivot row by 2 and adding it, not multiplying, adding it to the row we're changing, which is row 3. So row 3 is equal to twice row 2 plus row 3. Okay? I hope this matches whatever you've done on your own paper. I hope these things that I'm writing down agree with your solution. That would be wonderful if that's the case. All right, so let's write down the next tableau according to these two row operations, right? Okay. So let's do this row operation first. Okay. This is saying replace row 1 by multiplying the second row by negative 4 and adding it to the first row. So negative 4 times 0 is 0. Plus 0, 0. Negative 4 times 2 is negative 8. Plus negative 2, negative 10. Negative 4 times 2 is negative 8. Plus 0, negative 8. Negative 4 times 1 is negative 4. Plus positive 3 is negative 1. Negative 4 times 1 is negative 4. Plus 4 is 0, which is what we intended, right? Negative 4 times 0 is 0. Plus 1, 1. Negative 4 times 1/2 is negative 2. Plus negative 1, negative 3. Negative 4 times 2 is negative 8. Plus positive 20, that's positive 12. Okay, so the second row is the pivot row. Let's write it down as it is. Here's our pivot element. Like that. Okay, so let me double check these numbers. They look good. Okay, that's fine. Okay, so now we're done with this row operation. We move to this row operation here. This is saying replace row 3 by multiplying the second row by 2 and adding it to the third row. So let's do that. 2 times 0 is 0, plus 1, 1. 2 times 2 is 4, plus 1, 5. 2 times 2 is 4, plus 0, 4. 2 times 1 is 2, plus 2, 4. 2 times 1 is 2, plus negative 2, 0, which is what we intended, to get rid of this negative, right? And we just did that. 2 times 0 is 0, plus 0 is 0. 2 times 1/2 is 1. 1 plus 1/2 is 3/2. 2 times 2 is 4, plus 2 is 6. So, are we done? We are done. We are done because all the numbers in the objective row are positive. So this is in fact our final tableau. Okay, so we're going to be able to read the solution, solution of the maximum problem from these columns. Okay, look under the column x1. These numbers are all over the place, right? Negative 10, 2, 5. So the value of x1 is 0. in order for the variable x1 or any of these not to be 0, we must have zeros and one single 1 in that column, but that's not the case, so 0. x2 the same way, right? Like look at these numbers. So they're not zeros and a 1. So x2 equals 0. Look at x3 the same way. So x3 is equal to 0. Look at x4. That's nice, right? x4, we have zeros and a 1. So the value of the variable x1 in the maximum problem is read in the right-hand side column right across from the 1, okay, which is 2. And of course, the value of the objective function at maximum is 6. It's always in this corner right there. So p equals 6. So the solution of the maximum problem using the simplex method is that. So can we test this? Absolutely. I mean, if I look back at, let's see, at that. So here's the, so to test this, to test the solution, simply plug into the objective function so the objective function was this, was p equals x1 plus 2x2 minus x3 plus 3x4. So let's plug in. P equals 6, x1 equals 0, x2 equals 0, x3 equals 0, plus 3 times 2. So we end up with 6 equals 6. Is this valid? Yes. Right? So we can quickly test our solution if we're interested in that. All right. So we're done with that. Let's go over a word problem. Okay, suppose then okay. So I have a habit of underlining the quantities in a word problem, so that's easier, it makes it easier for me to find them as I look through the problem again. Each. Okay. Okay. Like that. Okay. So at the end of this, let me give you a hint. This is just a reminder that recall that profit, because it says we want to maximize profit, right? That's what they want to do. But profit is equal to revenue minus cost. Okay. Okay, so far, in the word problems that we did so far, I've mentioned that the first step in solving any problems, any word problem, you need to introduce your own variables. Without that, you cannot solve a word problem. So you can start with using x, y, z, or x1, x2, x3, but I prefer to use variables that are that match this context. In other words, so I'm going to read it again and say a toy store has shelf space to hold at most 60 baby dolls of 3 different types. Sleeping baby dolls. So I'm going to call the sleeping baby dolls S. Right? So I'm going to do that. So let me write that down here. And I'll scroll back up again so we can read the problem. But I'm going to say that S is number of sleeping dolls. Okay, and talking baby dolls, so I'm going to use T, capital T for that. Number of talking dolls. And also they have a walking baby doll, and let me use W as the variable for that. So W represents the number of walking dolls. Okay. Now we can begin. Once you introduce variables, it's a huge jump from no variables to this, because now you can start attaching information and meaning to each of these variables. And we've already done that to some extent, right? We already labeled it, but now we can attach information to it. And here's what I mean. So reading from the beginning, it says a toy store has shelf space to hold at most That's very important. We need to translate this whole sentence. See, that whole sentence, we need to translate it symbolically. The shelf space is at most 60 baby dolls, okay? So that means, given these variables, notice you couldn't do this if you had not introduced variables yet. So S plus T plus W must be less than or equal to 60, right? At most $60. So if we add up the number of sleeping, talking, and walking dolls, it should not exceed 60. It should be either equal to it or less than that. So this means the phrase at most translates into this inequality. Okay? So we're going to read more and translate this information into symbolic form. It says sleeping baby dolls cost $6 each. Okay? So we're going to attach that information to the variable that we introduced, right? Sleeping baby dolls, they cost $6. Talking baby dolls cost $7.50. So I'm going to attach that information to the T variable. Right? And walking baby dolls cost $9 each. $9, right? So far, we've translated all of this information into symbolic form. So if somebody comes and rips off this portion of the page, I won't miss it. Okay, I won't miss it. I have already captured that information. So let's read more. The store can afford to spend up to, that's very important, up to, that's a constraint, right? Up to. That means not exceeding $405 for the dollars. Okay, so hold on to that information in your mind and we get to that. The sleeping, talking, walking dolls resell for $12, $13.50, and $17 each, respectively. So this is the revenue, right? Anything that we sell to the customer, anything that customer pays us for selling them something, it's part of the revenue side of an equation, right? So for sleeping baby dolls, that would be, for sleeping baby dolls is $12. So I'm going to attach that information to sleeping baby dolls. So revenue from that selling sleeping dolls would be $12. Like that. Revenue for selling talking dolls is $13.50. $13.50. And revenue for selling walking dolls, it's $17. $17, right? Okay, so we have, and then also this one, the store can afford to spend up to $405. That gives us another constraint, doesn't it? Right? Because we know how much each one costs, $6, $7.50, and $9, and the store can spend up to that much. So let's write down, using this information, we're going to write down another constraint inequality. So let's do that. So 6S, right? Sleeping dolls cost $6 each. So 6x plus talking dolls cost $7.50. and walking dolls cost $9 each. That's cost to the store that orders these dolls. And that cost should not exceed $405. That's how much the store owner has to purchase these dolls. So far, from the shelf space constraint, so that first one is the shelf space constraint, right? The second one is the budget or budgetary constraint, right? That's how much the store owner has to purchase these dolls. And then we've translated everything here, and then except this still, we haven't made use of the revenue. The store wishes to maximize the profit. But so we need to, because of this piece, we need to create an objective function for the profit, not revenue, not cost, right? The store owner wishes to maximize profit. Right now, we have the information about revenue. But that's where this hint comes in, right? That's where this hint comes in. Profit is equal to revenue minus cost. So let's find our objective function, because so far what we found are the two constraint inequalities. So let's find the objective function. We need to do that. Okay, so we have the cost function. I'm just going by this hint. This is a very important hint. So the cost function is this one, is C equals 6 times S plus 7.5 times T plus 9 times W. The revenue function is equal to these numbers. Remember that the sleeping, talking, walking dolls resell for $12, $13.5, and $17 each respectively. So let's, and I have that information captured here. So 12 times S, this is the revenue function, right? Plus 13.5 times T plus 17 times W. You see, you introduce the variables and then you attach information to that variable, and that makes it possible for you to set up the constraint inequalities, and now we're working on finding the objective function. So that hint up there is telling us that profit equals revenue minus cost, right? Okay, so that means that P is equal to all of this, all of this, the 12S, plus 13.5T plus 17W, all of that, which is revenue, minus all of the cost, all of that, all of this. So all of this, so 6S plus 7.5T plus 9W, right? So we need to distribute this negative into that and then do the algebra on this. So let's do that. So we have t equals 12s plus 13.5t plus 17w, distribute this, minus 6s minus 7.5t minus 9w, right? Now let's do the algebra. We end up with p equals 6s, right? 12s minus 6s is positive 6s. 13.5t minus 7.5t, that's positive 6t, plus 17w minus 9w, that's 8w. So right there, we found the objective function, objective profit function. Okay, so now we have everything, and remember that none of these variables, st and w, can be negative, right? We can't, or the store owner cannot order a negative number of these dolls. Okay, and this is the ultimate question. The store owner or the store wishes to maximize its profit by ordering the appropriate number of each type of doll. So we're looking for the appropriate number of dolls which would help the store owner maximize its business profit. Okay? So let's clean this up and put it in order so that it's in front of us. So I'm going to rewrite all of this again in a neat way, because everything we did was to organize the information. And I'm going to write it here. So we want to maximize this profit function, right? The one we just figured out. P equals 6s plus 6t plus 8w. So I chose my variables so I can keep track of what's what. So I know this is sleeping dolls, talking dolls, and walking dolls. Okay, if you don't like this, you can use x, y, z, or x1, x2, x3. It makes no difference. So that's the that is the objective profit function, and we want, and this is subject to these constraints, which is s plus t plus w is that one. Right? I'm just going to rewrite it. Less than or equal to 60. And then this constraint, the budgetary constraint. So 6s plus 7.5t plus 9w less than or equal to 405. And of course, the positive, or the condition for a standard maximum problem, which is s must be greater than or equal to 0, t must be greater than or equal to 0, and w must be greater than or equal to 0. Right? Okay, so we have that in front of us. I suggest that you pause the video at this point and take the problem all the way to the end, and then come back to the video and compare your solution with mine. Okay? So I'm assuming that you've done that, and now you're back. Okay, so the first step is to set up the initial simplex tableau, which would be P for profit function, and then this time our non-basic variables are st and w, so s, t, w. We have two constraint inequalities, so we need one slack variable for each one, and then of course the right-hand side column and the objective row. So because because there's no p variable in either of these constraints, so we have 0, 0, and then 1 in the objective row. And then for S, that's the first constraint, we have 1, 1, 1. Grab those coefficients. We're going to have an S1 in that constraint to convert this constraint inequality to equality. 0 for S2, and of course 60 on the far right side. In the second row, we have these coefficients, 6, 7.5 for T. For W, we have 9, and then we have 0, 1, and then 405, right? In the bottom, at the bottom, in the objective row, remember that we have to rearrange the objective function, right? So we have P minus 6S minus 6T minus 8W equals 0. That's the objective profit function that we have. So now let's import these coefficients into the initial simplex Tableau. For P, we have 1. That's fine. For S, we have minus 6. For T, we have minus 6. For W, we have minus 8. And then we have 0, 0, and that's 0 in the right-hand side column. Right. So now, the pivot column, of course, is the column over the left-handmost, the negative number in the left-handmost spot in the objective row. So this is our pivot column right there. Both numbers in the pivot column are positive, so we need to investigate the smallest ratio. So let's do that. So we have 60 divided by 1, 60, right? 60 divided by 1. 405 divided by 6. What do we get when we do that? So 67.5, right? Here it is. So 405 divided by 6, 67.5, right there. So this is the smallest ratio here. That means that 1 is going to be our pivot element. Okay? And unfortunately, we don't have to do anything to it because it's already 1. So what are the row operations for converting this 6 and negative 6 to 0? Right? So the first row in this case is our pivot row. Right? That's our pivot row. And it's already 1 here, the pivot element. So the row operation would be to change this 6 to 0. We need to change row 2. How are we going to get a 0? Well, all we need is a negative 6. Where is the negative 6 going to come from? It's going to come from multiplying the first row by negative 6 and then adding it to the second row. So negative 6 times row 1 plus row 2. Okay, that's one of the row operations. So how are we going to get this negative 6 to be 0? All we need is add a positive 6 to this, and it ends up being 0. So where's the positive 6 going to come from? It's going to come from multiplying the pivot row by 6 and adding it to that. So row 3 would be equal to 6 times row 1 plus row 3. Okay, so these are the 2 row operations. I hope my solution so far matches what you did on your own paper. I hope that's the case. Okay, so we're going to do that. Let's do that. And we have, let me move this up a little bit, like that. So we have P, S, T, W, S1, S2, right-hand side column. And so the first column is, well, the first row is the pivot row, so let me write that down. Now we're going to carry out this row operation. And so this is saying multiply the first row, replace the second row by multiplying the first row by -6 and then adding it to the second row. So let's do that. -6 times 0 is 0, plus 0, 0. -6 times 1 is -6, plus +6, 0. -6 times 1 is -6, plus +7.5. That's positive 1.5. -6 times 1 is -6, plus +9. That's +3. -6 times 1 is -6, plus 0 is -6. -6 times 0 is 0, plus 1 is just 1. -6 times 60 is 300, -360. -360 plus 405, it's positive 45. So we're done with that row operation. Now let's focus on this row operation. This is saying replace row 3 by multiplying the first row by 6 and adding it to row 3. So 6 times 0 is 0, plus 1, 1. 6 times 1 is 6, plus -6, that's 0. 6 times 1 is 6, plus -6, it is, let's see, let me double check this. So again 0, yes, correct, 0. 6 times 1 is 6, plus -8, that's -2. 6 times 1 is 6, plus 0 is 6. 6 times 0 is 0, plus 0 is 0. 6 times 60 is 360. 360 plus 0 is 360. So are we done? No, we're not done, right? We still have this negative number in the objective row. So our new pivot column becomes this. And in that column, both numbers above the negative number are positive. So we need to investigate the smallest ratio. So 60 divided by 1, 45 divided by 3, and so 15 is definitely the smallest ratio. Right? So the 3 becomes the pivot element, which means we need to convert that to 1. So all of that. So the second row is the pivot row. Okay. All right, so what is the row operation for doing that? It's just row 2 equals 1/3 row 2, right? So row 2 equals 1/3 row 2. Okay, so let's carry out this row operation. Okay, so row 1 and row 3 don't change, right? So I'm going to write them down as they are. 0, 1, 1, and 1 again, and 1, and 0, and 60. Now this row operation, so this here, multiply the second row by 1/3. So 1/3 times 0, 0. 1/3 times 0, 0. That 1.5 is really 3/2, right? That's 3/2 multiplied by 1/3, right? So let me use a scratch paper here. So we're multiplying that row by 1/3, right? So 1.5 is equal to 3/2. Now we're multiplying that 3/2 by 1/3, right? So 3/2 times 1/3, it'll be 3/6, which is 1/2. Okay, so we end up with 1/2 there. Then 1/3 times 3 is 1, which is what we intended. That's the pivot element for us. 1/3 times -6 is -2. 1/3 times 1 is 1/3. 1/3 times 45, it's 15, right? 45 divided by 3 is 15. And the third row, let's write it as it is. Like that. So we know that this is our pivot column. We know that the second row is our pivot row. Pivot row. And now we need to convert the 1 and -2 to 0, right? So, and we're going to have to use the pivot row to accomplish that. So how are we going to convert this 1 to 0? All we need is add a -1 to it. So, and that 1 is in the first row, so row 1 would be equal to -1 times row 2, so minus row 2 plus row 1. So that's the row operation to convert this 1 to 0. Okay, so how are we going to get this -2 to be 0? Well, all we need is to add a +2 to this. Okay, where is the +2 going to come from? It's going to come from multiplying the second row by 2 and adding it to the third row. So we're changing row 3. So row 3 is equal to 2 times row 2 plus row 3. Right? So let's carry out those row operations. I'm going to do that here on the next page. Okay, so we have that. Hopefully I can fit it on the screen like that. And this would be page 15. All right, so we're going to have P, S, capital S for sleeping dolls, talking dolls, T, walking dolls, W, S1, S2, and the right-hand side column, right? Okay, and the objective row at the bottom. Okay, so let's carry out this row operation first. This is saying multiply the pivot row, which is the second row, by -1. Multiply this row by -1 and add it to row 1. Let's do that. -1 times 0 is 0, plus 0, 0. -1 times 0, 0, plus 1, 1. -1 times 1/2, that's -1/2, plus +1 is +1/2. minus 1 times 1 is minus 1. Plus 1, 0. Minus 1 times minus 2, that's positive 2. Plus 1, positive 3. Minus 1 times minus 1/3 is minus 1/3. Plus 0, we get minus 1/3. Minus 1 times 15 is minus 15. Plus 60, that's positive 45. Right? So far, so good. So the second row is the pivot row. Let's write it down as it is. Okay, now we're done with this row operation. Let's commence with this row operation now. Okay, like that. So this is saying to replace row 3, multiply the second row, which is the pivot row, by 2, and then add it to row 3. So 2 times row 2 plus row 3. So let's do that. 2 times 0 is 0. Plus 1, 1. 2 times 0 is 0. Plus 0, 0. 2 times 1/2 is 1. Plus 0, 1. 2 times 1 is 2. Plus negative 2 is 0, which we intended. 2 times negative 2 is negative 4. Plus 6, positive 2. 2 times 1/3 is 2/3. Plus 0 is 2/3. 2 times 15 is 30, plus 360 is 390. Okay, so I hope this matches what you have when you solve this problem on your own. And are we done? We are done, right? Look at the objective row. All numbers are positive. So this is the final tableau. Okay, all right, so let's read the solution of the maximum problem from these variables, right, from that. So look under S. You have 1, 1, and 2 zeros. Perfect. So the value of S is determined in the right-hand side column right across from 1. So 45. Look under T. The numbers are all over the place, right? 1/2, 1/2, 1. So that means the value of T is 0. The value of W, 2 zeros and a single 1. Perfect. So the value of W is in the right-hand side column, which is 15, right across from the 1. 15. And of course, the maximum value of the profit is $390. So this is the solution of the maximum profit for this problem. Okay, so to maximize the profit, the store owner has to order 45 of the sleeping dolls, none of the talking ones, and 15 of the walking dolls, and he or she can expect the profit to be $390 at maximum. Okay, I hope this all makes sense now that you have persisted throughout this video, and I thank you for persisting through these videos. So we've come to the conclusion of section 5.1 and 5.2. Next video will be about section 5.3, which is using the simplex method for solving the minimum problem. So I won't say much about it now because that video will clarify all of that, but all I will say that 80% of what you saw us work out through these maximum problems will be the same, but 20%, which is very important, 20% will be different. So please, when you watch the next video, 5.3, keep an eye on for those differences between the simplex method for solving a minimum problem as opposed to using it for solving a maximum problem. So for now, have a nice day, and I'll see you again next time.